In this video, I'm going to cover the concept in chemistry called the mole for the Unit 3, Section 3 EdPuzzle quiz. In this presentation, we're going to go over why chemists use moles, how to calculate molar mass, and also molar mass when it comes to polyatomic ions in parentheses. First, let's talk about why chemists use moles. So there's a problem in chemistry, and that is that atoms are very, very small. So we need to start using, instead of one atom at a time, we use a standard number of atoms whenever we perform reactions in the lab. So instead of using one atom, we use what's called a mole's worth of atom. And a mole is a standard number of atoms, that is that number you see on screen. However, we usually abbreviate this as 6.02 times 10 to the 23 atoms. A mole is a very large number of atoms. So when it comes to moles of different elements, if we look at things like hydrogen or copper or oxygen, it doesn't matter what kind of atom we have, what kind of element. 1 mole is always 6.02 times 10 to the 23 atoms, regardless of that element. So how do we do something with this? How do we calculate molar mass? Well, first we got to talk about atomic mass. Different atoms have different masses because they have different amounts of protons, neutrons, and electrons. If we look at something like hydrogen, hydrogen has a very light mass, whereas copper has a very heavy mass. Because different atoms have different masses, moles of those different atoms will have different masses as well. This might make a little more sense by looking at an example. The periodic table lists every element, and it also lists the mass if we have 1 mole of that element in atoms. So if we look at, for instance, the element lithium here, at the very bottom, we'll see that 6.94. That tells us the molar mass of that atom, of that element. So lithium, if we have 1 mole of lithium atoms, it's going to weigh 6.94 grams on our scale. Now, what about compounds? Well, if we have a compound like CuCl2 here, in order to calculate its molar mass, we need to follow a series of steps. First, we're going to count the number of each element. In this compound, we have 1 copper atom and 2 chlorine atoms. Next, we'll set up our problem. Since there's 1 copper atom, we'll do 1 times the mass of copper, and we'll add on the next element, plus 2 times the mass of chlorine, because we have 2 atoms of chlorine. Next, we'll use our periodic table to fill in those molar masses. Copper, or Cu, weighs 63.55. Chlorine weighs 35.45. I just plugged them in for their masses. Next, we will solve our multiplication. 1 times 63.55 is 63.55. The plus just comes down. And 2 times 35.45 equals 70.9. And last, we'll just add everything up. 63.55 plus 70.9 is going to equal 134.45. Now, this number means that if we have 1 mole of CuCl2, it's going to weigh this much on our scale. Let's do a quick check-in. For our first question, why do scientists need to use the mole when doing lab work? Go ahead and answer on the EdPuzzle. This is because atoms are too small to work with. We need to use a large number of atoms at one time. For our next question, how many atoms are in 1 mole of something? We always have 6.02 times 10 to the 23 atoms, regardless of if it's any kind of all elements are going to have this many atoms in 1 mole. And finally, what is the molar mass of the element nitrogen by itself? From our periodic table, we can see that nitrogen weighs 14.01 grams for every mole. That's the number right here on the bottom of nitrogen's periodic table entry. Now let's take a look at a problem where we actually calculate the molar mass. What is the molar mass of the following compound? H2O2. Go ahead and calculate that mass and answer the question on your EdPuzzle. To solve this problem, you'd first need to find oxygen and hydrogen on the periodic table. I have them up here. We would then set up our problem, 2 times H because there's 2 H's, plus 2 times O because there's 2 O's. Plug in those molar masses from the periodic tables, multiply, and then add them up to get 34.02 grams per mole. Let's try a different example What is the molar mass of the following compound, Ca3P2? In this example, we'll put up our periodic table entries in the top right. We'll set up our problem the same way. Add in those molar masses right here. Multiply to get this addition problem, and then add up to get 182.18 grams per mole. One more time, what is the molar mass of this compound, MgF2? Go ahead and solve that out and answer on the EdPuzzle. First, here are our entries from the periodic table. Next, we'll set up our problem the same way. Plug in our molar masses, multiply, and then add up to get 62.31 grams per mole. Now moving on to our last topic, using parentheses with molar mass. So when it comes to a compound with parentheses, such as we have here on the left side, we need to add a step at the beginning of our process. First, we want to multiply the number outside the parentheses to every element in the parentheses. For instance, this Sn is outside the parentheses. It doesn't change. But this 2 on the very end, it gets multiplied to everything in the parentheses. So 2 times 1s gives us 2 s's, and 2 times 3 o's gives us 6 o's, 2 times 3. That gets us to Sn S2 O6. From there, the problem is exactly the same. 1 times Sn plus 2 times S plus 6 times O. Plug in the molar masses from the periodic table, multiply, and then add up. So it's a very similar process. You just have to change that parentheses, multiply the number at the very end by everything in the parentheses. Now let's have you try. So for this problem, please find the molar mass of the following compound, MgNO3 Make sure to first get rid of those parentheses. The way you'd solve this problem is first by using your periodic table entries for Mg, N, and O. Our formula would then change. We'd multiply 2 times 1n to get 2 n's, and 2 times 3 o's to get 6 o's. And then the problem is very similar to before. 1 times Mg plus 2 times n plus 6 times O. Plug in those masses from the periodic table, multiply, and then add them up to get 148.33 grams per mole. And for our last problem, try that one more time, but with the compound NH4 with a 3 outside the parentheses, P. What is the molar mass of this compound? First, we'll get NH and P from our periodic table. Next, we'll multiply 3 times 1n is 3 n's, 3 times 4 h's is 12 h's, and P is left alone. It's not in the parentheses. From there, we'll set up our problem. 3 times n plus 12 times h plus 1 times P. Plug in the masses from the periodic table, multiply, and then add them up to get 85.12 grams per mole. And that is your final answer. I hope this EdPuzzle helps you understand calculating molar mass a little bit better.